Hi everyone, and welcome back to Conquering Math, where it all adds up. Today we'll be talking about the products of powers rule. Products of powers is useful in a lot of scenarios, especially in science and especially in computers. You'll find that in computers we actually store information based on powers of 2. So we use products of powers all the time in our everyday lives without even knowing it. We'll be talking about gigabytes of data later in this lesson, so you'll be able to see one example of how this is used in real life. Let's take a look. Today's learning target is I can apply the products of powers rule to find products of powers that have the same base. So the rule is that 2 or more powers with the same base can be multiplied by adding their exponents. For example, if we look at 8 to the second power times 8 to the third power, we can rewrite that as 8, and then the exponent would be 2 plus 3 from the second power here and the third power here. And when we add those together, we would get 8 to the fifth power. Another way of looking at it is by splitting it up. So 8 to the second power is 8 times 8. 8 to the third power is 8 times 8 times 8. And so if you multiply all of those together, you'll see there's 1, 2, 3, 4, 5 8s being multiplied. So we have a base of 8 and an exponent of 5, and the power is 8 to the fifth power. Now let's take a look at a few examples. In example number 1, we need to rewrite the expression as a single power. We have x to the third power times x to the third power. Now we can write this out as x times x times x times x times x times x. And then if we multiply all this together, we've got 1, 2, 3, 4, 5, 6 x's. So we have x to the sixth power. Now we can make that simpler by applying the rule. So we can say x to the third power times x to the third power equals x to the, and then as the power we'll write 3 plus 3. And we know that that means x to the sixth power. So this bottom method right here, that's where you're using the product of power rule. This top method here is just showing why it works. Let's move on to example number 2. In example number 2, we need to once again rewrite the expression as a single power, and we have negative 5 to the fifth power times negative 5 to the second power. And yes, those parentheses are important. They tell us that the base is negative 5, not 5. So once again, we can write this out the long way without using the rule. So negative 5 to the fifth power times negative 5 to the second power looks like this. You'll notice in the first one here, and I used brackets to hold this all together, there are 1, 2, 3, 4, 5 negative 5s being multiplied together. And in the second one here, we have the factor negative 5 is being used twice. That's for negative 5 to the second power. And if you count that up, there's 7 of them. So that means that negative 5 to the fifth power times negative 5 to the second power is negative 5 to the seventh power. Now again, that's the long way to do it. Using the product of powers rule, we could say negative 5 to the fifth power times negative 5 to the second power. And then we would write negative 5, and then the exponent would be 5 plus 2, which gives us negative 5 to the seventh power. Moving on to example number 3, we need to simplify the expression. 4 to the fourth power times a to the fifth power times 64. Now if you look at this right off the bat, it looks like we can't do anything. The rule is that we can only combine using the product of powers rule if the bases are the same. So what do we need to do here? Well, we can first rewrite it and put the constants next to each other. So 4 to the fourth power times 64 times a to the fifth power. Now again, we've got a variable here, so we can't combine that with the other two pieces. But what we can do is turn 64 into a power of 4. So that's what we'll need to do. And 4 times 4 is 16, times 4 again is 64. So what that means is that 64 is equivalent to 4 to the third power. So we can rewrite it as 4 to the fourth power times 4 to the third power times a to the fifth power. And if we look here, we have 4 to the fourth and 4 to the third. And so we're going to go ahead and add those together. And that becomes 4 to the seventh power times a to the 5th power, or we could say 4 to the 7th power, a to the 5th power, without the dot in between, just like you do when there's no exponents there. All right, now we're ready for our application problem. Digital storage, for example on your phone, your computer, your tablet, is based on a powers of 2. 1 gigabyte of storage is equivalent to 2 to the 30th power bytes. Spencer just bought a new smartphone with 128 gigabytes of storage. How many bytes of storage are available on Spencer's phone? Write your answer as a single power of 2. So the first thing we should do is we should underline the important info here. We know that 1 gigabyte is equivalent to 2 to the 30th power bytes. So we'll go ahead and we'll underline that, and 1 gigabyte. And then Spencer just bought a new smartphone with 128 gigabytes of storage. So that's our total amount right there. So those are important. We'll want to write those down. So each gigabyte is 2 to the 30th bytes, and the phone has 128 gigabytes of storage. Now that we know that, this is a multiplication problem. We want to know the total amount, so we'll go ahead and multiply those together. 2 to the 30th power times 128. And just as in the previous problem, we need to rewrite 128 as a power. In this case, we need the base to be 2. So we need to rewrite 128 as a power of 2. If you're not sure what that number is, you can go ahead and use a calculator and just keep plugging in 2 times 2 times 2 until you get to 128, or your other option is you could divide it out and keep doing that and then see how many 2's you need. So it turns out that 128 is 2 times 2 times 2 times 2 times 2 times 2 times 2, which is much easier to say as 128 equals 2 to the 7th power. So going back to the start, we had 2 to the 30th power times 128, which we now know we can rewrite as 2 to the 30th power times 2 to the 7th power equals, and then again, we're adding these together right here, 2 to the 37th power. So we could say that Spencer's new smartphone has 2 to the 37th bytes of storage. So as a review, today you learned to apply the products of powers rule to find products of powers that have the same base. Remember, the product of 2 or more powers with the same base can be found by adding their exponents. And don't forget that they have to have the same base, otherwise it doesn't work. So you can't combine powers with a base of 2 and a base of 5, or powers with a constant base and a variable base. It doesn't work, only if it's the same base. Thanks for watching this episode of Conquering Math, where it all adds up. Make sure to check your assignment posting from your teacher for your next steps. Remember that you can pause and rewind this video as much as necessary to help you understand the problems. Thanks for watching. I'm Pat Long, and I'll see you next time.